Hello and welcome to this short explanation video for the Haskell left and right folding functions. First, I'm going to show you the type signatures and the definitions of the two functions, and then I will proceed to show you some examples. These are the definitions of the two functions. We start by looking at foldl, which stands for fold left. This function takes a function as its first argument. This function expects two arguments, one of type A and one of type B, and it returns something of type A. Next to this function, it also takes an argument of type A and a list of type B. After this, the function returns something of type B. The type of the foldr function, which stands for fold right, looks very similar to the foldl function, as you can see on the screen here. The right fold function also expects three arguments, a function that expects an argument of type A and an argument of type B and returns something of type B, and it also expects an argument of type B and the list of type A. This function returns something of type B. Even though the type and definitions looks very complex, these functions are very easy once you get an understanding of how they work. The definitions are listed on this sheet under the types. If you would like a good exercise, you should pause the video and try to figure out what both functions do and what the differences are between the two functions. On the next slide, I will explain how they work and I will show you some examples. I hope that by now you have a slight idea of what the function does. If you don't, that's also no problem. Let's look at some examples. We will start by the left fold function. This is the definition of the left fold function that we talked about before. I also listed the core idea behind this function. Now let's move on to a simple example. We feed the first argument the division function, the second argument the number 64, and the third argument a list with values 4, 2, and 4. What this function does is take the second argument, which in this case is 64, and the first value of the list in the third argument, which here is 4, and it applies the function from the first argument to them. In this case, it would divide 64 by 4. This gives the result 16. Then it does the same thing, but instead of using the 64 from before, it is fed with the result of our last calculation, which here is 16. And instead of using the first value of the list, we now use the second value. This means that now we divide 16 by 2. This gives us the value 8. Then we do this one more time, since there's only one more item in the list. We take our last result, which is 8, and apply the function to this result and the next item in the list, which is 4. This gives us 8 divided by 4. This is 2, and our final answer is 2. Let's do one more example. In this case, we have the function 2 times x plus y as our first argument, the number 4 as our second argument, and the list with values 1, 2, and 3 as our third argument. We start by doing the same as before. We apply the function between the second argument and the first value in our list. In this case, 4 is our x and 1 is our y. We fill in the formula and get the value 9. We then apply the function to this 9 and the second item in our list. This gives us 2 times 9 plus 2, which is 20. We do this one more time for the result we got from the last calculation and the last item in our list, which gives us 2 times 20 plus 3, which is 43. Our final answer is 43. I hope that you now understand the left folding function. Now we move on to the right folding function. This here is the type and the core idea behind the function. It is very similar to the last function, but it applies the folding function from the right. Let's take a look at an example here as well. We feed the first argument the division function, the second argument the value 2, and the third argument a list with values 8, 12, 24, and 4. We then do the same as before, but now we start with the last item in the list instead. We take this last item, which is 4 in this case, and we apply the function to this value and the value of the second argument, which is 2 here. So we divide 4 by 2. This gives us the result 2. We then repeat this by picking the next to last item in the list and our result from the last calculation. We apply the function to these two values and we get 24 divided by 2, which is 12. Then we do it all again for this new value and the second item in the list, giving us 12 divided by 12, which is 1. And lastly, we do this for the first item in the list and the last result, giving us 8 divided by 1. This gives us the final result of 8. If we look back at the core idea behind this function and we apply it to this case, this here would be what you get. I hope that by now you understand the left and right folding functions of Haskell, and you understand the usefulness of these functions. Thank you very much for watching and goodbye.